Welcome everyone. In this video, I will discuss about the topics general solution of trigonometric equation. In this class, I will discuss only the basic concept of solving general solution of trigonometric equations and common mistakes done by the students. So before we start, we should know some basic concepts. So look, we need these concepts. So we know general solution of sin theta equals to 0 equals to tan theta is theta equals to n pi. Tan theta cos theta equals to 0 equals to cot theta. Same solution is theta equals to 2n minus 1 into pi by 2. Here n belongs to z. Same n belongs to z. Now cosec theta cannot be 0 and sec theta cannot be 0. So we do not get any solution. These are impossible cases. Now if right hand side is non-zero, then what are the formulae? So sin theta equals to sin alpha. This also implies cosec theta equals to cosec alpha, and general solution is theta equals to n pi plus minus of 1 to the power n into alpha, and tan theta equals to tan alpha, that is cot theta equals to cot alpha. If we take reciprocal, you get same theta equals to n pi plus alpha. Cos theta equals to cos alpha. General solution is theta equals to 2n pi plus minus alpha. In all cases, what is n? N is integer. So these are the basic formula. Now there is another theory also, how to solve equation of this type. So solve this one. Solve a sin x plus b cos x equals to c. Also state condition for existence of solution. Existence of solution. These equations. So we know a sin x plus b cos x equals to c. So we have to express this expression in terms of single sine and single cos. That is why we have to put a transformation. So what is the transformation? We know we can put a equals to r cos alpha, b equals to r sin alpha. Therefore r equals to root over a square plus b square, and tan alpha equals to b by a. That is alpha equals to tan inverse b by a. That is r and alpha is expressible in terms of A and B. Now putting value of A and B, putting value of A and B in 1, what we are getting? So putting the value, so A R cos alpha into sin x plus R sin alpha into cos x equals to C. So finally sin x plus alpha equals to C by R. Omitting one step, C by root under A square plus B square. Now we know sin cos, value of sin lies between -1 to +1. If value of the expression cy square plus b square lies between -1 to +1, then we get solution. So we can write solution of the above equation exists. Solution of the above equation exists if -1 less than equals to sin x plus alpha less than equals to 1. So putting values, so -1 lesser than equals to c by root over a square plus b square lesser than equals to 1. So minus c root of minus a square plus b square lesser than equals to c lesser than equals to a square plus b square. So this is the condition for existence of solution. We can write also in this form mod c lesser than equals to root over a square plus b square. So this is condition for existence of solutions. Now we have sin x plus alpha equals to cy root over a square plus b square. Suppose this one is sin alpha. If it is possible value, so we suppose this value as sin alpha. So from our basic formula, what is the solution? Therefore solution is x plus alpha equals to n pi plus minus of 1 to the power n into alpha. So x equals to n pi plus minus of 1 to the power n, look, we have already considered alpha. So we cannot take this as alpha. So you change it as beta, sin beta. So x plus alpha, this is beta. So n pi plus minus of 1 to the power beta minus alpha. So n belongs to z. Where alpha and beta, where alpha equals to, so what is alpha? Alpha is tan inverse b by a and beta equals to sin inverse c by root over a square plus b square. So this is general case, but practical problems are very simple. What is the rule of solving practical problem? We divide both sides by root over a square plus b square. So note solve problem, we divide both sides by root over a square plus b square. So this is theory. So condition for existence of solution we have to recall. So let us consider a problem. So solve sin x plus cos x equals to 1. Now both are same angle. So by the above theory we can divide both sides by 1 square plus 1 square. So 1 by root 2 into sin x, 1 by root 2 into cos x equals to 1 by root 2. So sin x into sin pi by 4, cos x into cos pi by 4 equals to 1 by root 2. So we can use formula of cos x minus pi by 4 equals to cos pi by 4. So what is general solution? X minus pi by 4 equals to 2n pi plus minus pi by 4. So x equals to 2n pi plus pi by 4 plus minus pi by 4, n belongs to z. Now this is general solution. This is general solution. There is a term principal solution. What is principal solution? Principal solution. So you know solution lying in the interval 0 to 2 pi is called principal solution. So solution of equation which lie in solutions 0 to 2 pi is called principal solution. Principal solution. Principal solution. So putting n equals to 0, 1, 2 we get. So look, putting n equals to 0. So what is x? X equals to 0 or pi by 2. So look, if we take plus sign, then this is pi by 2 minus sin pi. If we take n equals to 1, then 2 pi, and if we take plus sign, then 2 pi plus pi by 2. So if we take minus sign, so 2 pi. These are solutions in between 0 to 2 pi. So these are principal solutions. So principal solutions. Now one thing is to be noted. So look, so general solutions, form of general solution is not unique, because if you look, if we consider the above problem and if we write it in terms of cos x, so we can express it also cos x. So cos x minus pi by 4 equals to cos pi by 4. So what is general solution? X minus pi by 4 2n pi plus minus pi by 4. So x, this is in terms of cos, sorry. If we express it in terms of sine, then it is sine x plus pi by 4. We have already considered in terms of cos. So general solution is x plus pi by 4 equals to n pi plus minus of 1 to the power n into pi by 4. So x equals to n pi plus minus of 1 to the power n into pi by 4 minus pi by 4. Look, in the previous case, solution was like that: 2n pi plus minus 2n pi plus minus pi by 4 plus pi by 4. And in case of sine, we are getting this. They look different. They look different form, but they represent same set of solutions. So we do not bother about answer. So we should look. If we put n equals to 0, x equals to what? 0. If we put n equals to 1, so what is x? If we put n equals to 1, this is pi, this is plus pi, minus pi by 4, this is minus pi by 4. Look, we are getting answer pi by 2. So n equals to 2 also. So what is x? 2 pi plus pi by 4 minus pi by 4 equals to 2 pi. So we are getting same set of solutions. This is the observations. So in some books, answer may be given in this form. In some books, but they represent same set of solutions. Now, some observations. So look. Some observations. So sin x plus cos x equals to 1. So if we take square of it, what we are getting? 1 plus 2 sin x cos x equals to 1. That is sin 2x equals to 0. So what is 2x? 2x equals to n pi. 2x equals to n pi. So x equals to n pi by 2. So n belongs to z. So what are the solutions? 0, pi by 2, 0, pi by 2, n equals to 1, 2, pi. Then 3 pi by 2, 2, 4, 2 pi, and so on. But look, if we put x equals to pi, then sin pi is 0, cos pi is minus 1. So 0, cos 0, 1, satisfied. Pi by 2 satisfied. Pi does not satisfy it. Cos 3 pi by 2, 0. But sin 3 pi by 2 is minus 1. Do not satisfy it. 2 pi satisfy it. So, what is our observations? So, if we take square of the equations, then degree of the equation is increased. In this case, all the solutions do not satisfy the equations. Here, pi, 3 pi by 2, do not satisfy the equation. They are called extraneous root. Extraneous root. Extraneous roots. They are obtained by squaring additional roots, squaring of the equation. So degree of the equation increased. That is why we are getting this rule. So we always try to avoid for solving problem, try to avoid squaring. If it is not possible, we verify whether solutions satisfy the equations or not. This is our first observations. So to solve equations squaring is avoided. If not possible, if it is not possible, check whether solution satisfy or not. So this is our first observations. Now observations 2. So these are the basic mistakes done by us. Number 2. So write tan 3x minus tan 2x by 1 plus tan 3x into tan 2x equals to 1. We consider this problem. So solve. So look, obviously we write this is a well-known formula. So this is formula of tan a minus b. So this is tan x. Tan x equals to 1. So what is x? X equals to tan x equals to 1. So x equals to n pi plus pi by 4. N pi plus pi by 4. So what are the solutions? Pi by 4. Pi plus pi by 4. That is 5 pi by 4. 2 pi plus pi by 4. 9 pi by 4. So look, these are the solutions. But if we put x equals to pi by 4, tan pi by 2, this is undefined. So this is not solutions. Similarly, if you put this, the equations, so look, tan is not undefined. So this should be kept in mind. So what is our observations 2? Observations 2. The answer should not come. The answer solution should not contain such value for which equation is undefined. So this is also common mistakes. So in general we write this, but look, you think, you see whether this value, this can, the given function is defined or not. Next, now observations 3. So sine 2x, all of you know it. So try to recall. So if you simplify 2 sine x cos x equals to sine x. So sine x common. So 2 cos x minus 1 equals to 0. So either we get sine x equals to 0. So what is x? X equals to n pi. Cos x equals to half. X equals to 2n pi plus minus pi by 3. We are getting these two sets of solutions. So if we put, suppose x equals to 0, so sine 0, 0, this is satisfied. If you put x equals to, suppose pi by 3, sine pi by 3, sine pi by 3, what? Half. Sine 120 also half. All values satisfied. But look, if you solve this in this way, look again. So 2 sine x cos x equals to this. So what we are getting? 2 cos x equals to 1, cos x equals to half. So we are cancelling sine x. But it is possible when sine x not equals to 0. So look, in this case, 2n pi plus minus pi by 3. In this case, we lost one set of solution. So look, what is our third observation? Do not cancel any term at the numerator. So write, never cancel terms. Never, this is our observation, never cancel terms. Never cancel terms containing unknown variable. 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 Which are given in product form. Given in product form. So never cancel this. It may lose solution. Now observation 4. Observation. Today we are considering only basic concept. Basic concept. In next classes, we shall consider typical problem, important problem, and so on. So what is our observations 4? Let us consider the equation tan x plus sec x equals to 2 cos x. So look, sin x by cos x plus 1 by cos x equals to 2 cos x. So sin x plus 1 equals to 2 cos square x. So in terms of same trigonometric ratio, this is 1 minus sine square x. Now 2 sine square x plus sine x minus 1 equals to 0. Then factorize 2 sine square x plus 2 sine x minus sine x minus 1 equals to 0. So sine x plus 1 and 2 sine x minus 1 equals to 0. So sine x equals to minus 1 and sine x equals to 1. So look, if we consider principal value, what are the values? X sum minus 1. So you can take, this is 3 pi by 2. Sin x equals to half. X equals to what? Pi by 6. 5 pi by 6. But look, at x equals to 3 pi by 2, x equals to 3 pi by 2, sec x is not defined. Sec x is not defined. Cos 3 pi by 2 0, sec 3 pi by 2 is not defined. So look at the denominator. So look, what is our observations 4? This is our observation 4. Look, in this case, all the solutions do not satisfy the given equation. So what is our observations? Check that denominator is never 0. Check that denominator is never 0. Never 0. Never 0. Denominator is never 0 at any stage. At any stage. At any stage while solving equation. While solving equations. While solving equation. So that is you. So case 3 says you cannot cancel same term. Look, 2 sin x cos x equals to cos x. You cannot cancel cos x because cos x is that the denominator. But if you get suppose 2 sin x plus 1 by cos x equals to 1 by cos x, you can cancel this because it will be undefined for such values. So you can cancel denominator term at the denominator but never from numerator. So these are some basics observation. Basic observation. Now, so look, this equation, we know a sin x so in JEE many times these basic problems often come. So what type? So write a problem. Root 3 cos x plus sin x equals to 4 has number A, one solution, two solution, many solution, D, no solution, no solutions. So for this type of problems are very easy. You know, you have to divide throughout by this. But you first check whether condition of solvability is satisfied or not. Look, if we here a equals to root 3, b equals to 1, so what c equals to 4. So what is our condition? A square plus b square lesser than equals to minus this. So what we are getting, a square plus b square, this is 2, lesser than equals to 4, lesser than equals to 2. This is not true, which is not true. So how many solutions? No solutions. So you should know the concept. So very simple problem. Now these problems. So if we write like that, root 3 cos x plus sin x, the same problem, look, has one solution, two solution, many solution, no solutions. So what will be answer? You look. So here we get minus 2 and c is 1, lesser than equals to 1, lesser than equals to 2. So 1 lies between these. So which is true? Which is true? Therefore, how many solutions you are getting? Infinitely many solutions. So that is many solutions. So this should be noted, this type of problem. Now, write some problem using this theory. So write a sin x plus b cos 2x, b cos 2x equals to 2a minus 7. 2a minus 7. Find a restriction on a for which equation has solution. So we are considering today basic problems. Basic. Look, this is x, this is 2x. So we cannot use the above theory. So our main aim is to express it in terms of single trigonometric ratio. So a sin x plus this is not the corrective, this is only cos x. So a sin x plus cos 2x. So a sin x. So 1 minus 2 sin square x equals to 2a minus 7. So transfer all term to left hand side. In same side, 2 sin square x minus a sin x. Transferring to this, plus 2a minus 8 equals 2. So what is sin x? If it is not factorizable, so a plus minus b, a plus minus a square minus 4 into 2 into 2a minus 8. So by 2 into 2. So finally what you are getting, a plus minus a square minus 16a plus 64. So this is obviously square term, a plus minus a minus 8 by 2. So if you take positive sign, 2 into 2, this is 4, sorry. If you take positive sign, so 2a minus this. So a minus 4 by 2, a minus 4 by 2. And if we take negative sign, this is 2. So sin a equals to 2. This is not possible. So what we are getting? So look, sin x equals to a minus 4 by 2. Now we have to find a relation in terms of. So what is our theory? We know minus 1 less than equals to sin x less than equals to 1. So minus 1 lesser than equals to a minus 4 this. So minus 2 lesser than equals to. So this is in equation. So finally adding 4, 2 lesser than equals to a lesser than equals to 6. So this is the restriction. A lies between 2 to 6. Next, today I have already told that we shall consider only the basic problems. Now, next one more problem. So look, this one, e to the power sin x. So all are well known problem. E to the power minus sin x equals to 4. This one. So solved if possible. Or it is given in this form in competitive exam. 1 solution, 2 solution, 3 solution, none. So we put a transformation sin x e to the power sin x equals to t. So we will get t minus 1 by t equals to 4. So t square minus 1 equals to 40. So t square minus 40 minus 1 equals to 0. So look what we are getting. T equals to 4 plus minus 16 minus 4 into 1 into minus 1 by 2a. So 4 plus minus 20 is 2 root 5 by 2. So what is t? E to the power sin x equals to 2 plus minus root 5. 2 plus minus root 5. So we are getting this relation. E to the power sin x. Now you know e to the power sin x. You look, e to the power sin x belongs to e to the power minus 1 to e to the power 1. Because maximum value is minus 1. But look here, e to the power sin x. So e to the power sin x. If we take plus sign, root 5. So 2 plus 2 point something. That is, it is greater than 4. But what is the maximum value? Maximum value is 4. So this value is not possible. Now e to the power sin x, if we take negative sign, 2 minus root 5, 2 minus 2 point something. So this is negative 1. But look, e to the power exponential function, this is always positive. 1 by, this is small value, but never negative. So negative, this is not possible. So what is our final conclusion? This has no solution. So look this step, e to the power sin x. lies between 1 by e to e. 1 by e is positive, but e to the power sin x equals to 2 plus root 5. This is greater than e. What is e? E is, 2.718. So, not possible. This one is negative. This is also not possible. Next, we again consider an important problem. So solve cos to the power 50x minus sin to the power 50x equals to 1. Equals to 1. So look, power is very large, so we cannot solve it by ordinary method. So how to solve? Look, if we transfer this term to right hand side, so what we are getting is, so so this side is greater than equals to 1. This side is greater than equals to 1. So 1 plus sine to the power 50x greater than equals to 1. So if it is 0, 1, otherwise it is 1. If it is 0, then value is 1. Non-zero, greater than 1. But cos to the power 50x cannot be greater than 1. So this is greater than 1. So cos to the power 50x cannot be greater than 1. So what is the only possible case? Possible case is you have to write sin x equals to 0. If sin x equals to 0, then this is 1 cos to the power 50. So this is even power. So maximum value is 1. So what is general solution? X equals to n by n belongs to z. So today we are discussing only some basic problem. In the next class, I will take 2 or 3 classes. One more to important problem of general solution, and number 3 typical problem of general solution of trigonometric equations.